Okay, so I'm going to make a video here about the chain rule, which is I think 11.7 of our textbook. And I'm going to write here what the chain rule is. The chain rule is what we use when you take the derivative of the composite function or the composition of two functions. There's many ways to write it. One way is to write, you have to do the derivative of f, but it's something weird here, still valued at g, and then you have to multiply the derivative times the derivative of g, so dg dx. Another way to write this is just something like f of g prime is just f prime of g times g prime. This is a times here, not a multiplication. So a simple example to write this down, to keep some ideas in our head. Let me do an example here. So, for example, if your function f of x is x squared, and g of x is 5x plus 1, then f of g of x, to remind you, is f when you plug in 5x plus 1. So this is really just the function 5x plus 1 quantity squared. Okay. So usually the hard part of these problems is that they don't present to you like that. They tell you just somewhere else. So you define the derivative of the function 5x plus 1 squared. And it's part of the question, it's part of your job, or whoever's in the question, to identify this like the composite function of, like over here. It's a composite of the function x squared with the 5x plus 1. Yeah, so you need to identify who is your f, who is your g, how to apply this rule, basically, using this context. So that's probably the hard part. Once you realize that, it becomes automatic. So we need a lot of practice to get this. So basically, the derivative of this becomes, how do you take the derivative of x squared? Well, the derivative of x squared is just 2x, right? So f prime of x is just 2x. So here you don't put 2x, you put 2 times, this is the whole part about it. It's if the derivative of f, but evaluated at g. So it's 2 times 5x plus 1. And then that's this part. Yeah. It's the derivative of f, but evaluated at g. It's still a composite function of f prime, where your input is g. And then the derivative of g, in this case the derivative of g is 5. So you have to multiply by 5. So your final answer would be 10 times 5x plus 1. If you distribute that or not, it shouldn't be a problem. Something to be aware of is, of course, in my math lab, you might get it wrong if you can simplify. It might ask you to have it factored, but in the real life, in the exam next week, it doesn't matter. I'll be grading this, and if you do answer like this, or if you multiply it out, that's not a big deal unless I specifically ask you to write it one way or the other. So this is a very basic example. I want to now do an example somebody asked in the website in Canvas. So somebody asked to talk about this derivative. I think it might be an example in the book or in the homework. It says the natural log of the natural log of, let me be sure what it says, of 15x, I believe. It doesn't matter what it is, but I'll do the same example that they asked me. And something to recognize that it has the absolute value here, just because if you remember from the natural log definition, it's only defined for positive numbers. So this only makes sense if your input to natural log is positive. So it has the absolute value there. But don't basically just to see that it's part of the natural log restriction, but it's not going to be a part of your derivative. So the thing to remember here is that the derivative of the natural log is just 1 over x. But now this is a chain rule, right? So I'm doing the outside function. This is the natural log, and I'm evaluating all this thing, right? Okay, so now who is the derivative of the natural log? It's 1 over that. So I copy that down here. And then I have to times it by the inside function, which is this. Right, so I'm going to write it down here. It's still times the derivative of the inside function, which is again the natural log of 15x. We're going to write 15x inside the absolute value. Okay. So this is the two-step, right? It's the derivative of the natural log function is 1 over the input, and the input was all that. So all this gets down here, and then times the derivative of the inside. The inside function is natural log of 15x, so it goes in here. So now what is the derivative of natural log of 15x? So I have this part here. And who is the derivative of natural log of 15x? Well, it's again 1 over 15x times the derivative of 15x. I'm writing too many steps here, but maybe this was, right? I have to do like another chain rule here, right? The derivative of this part here is again the 1 over this quantity, then times the derivative of that. It's over here. So this derivative is a 15. So okay, so this becomes, my final answer is going to be 1 over natural log of 15x times 1 over 15x times, this derivative is 15, correct? So that 15 cancels this 15, so I think our final answer is 1 over absolute value of x natural log of 15x. So I think this would be our final answer. So I hope this example helps. So these two examples illustrate. So the one up here was a very basic example to understand what's happening. You're almost never going to explicitly write who is f and who is g, and I recommend that you don't start doing that. Like don't write here who is f and who is g and write down the steps. If you have to do it for a couple times, but it gets very confusing after a while. Later on, you've been doing this so many times that it's going to be automatic. Just you take the derivative as the bigger function, still evaluate at the inside function, and then you don't have to not forget to still multiply by the derivative of the inside function. Yeah, that's the big idea of the chain rule. Okay, I hope that helps, and keep asking questions. I'll make videos. Okay.